I mainly work with lasers and atoms, and so I'm very much laser oriented. Everything I do is sort of revolves around lasers and optics. And what I do is I laser cool atoms to tens of microkelvins. So we take a beam of atoms and we shoot a laser beam the opposite direction. And counter to your sort of normal intuition, lasers are extremely cold. They're very monochromatic, which means they have a very, very, very narrow energy spread. The photons are coming along with lots of energy, but they all have exactly the same energy. So as Professor Jeff Opat, used to be in the department, would say, it's like putting a brick in the freezer. The freezer then is very cold, and if you throw it at somebody, it hurts when it hits them, but it's still very cold. So a laser is very cold, and it sucks the energy out of the atoms. I can tell you about that in class, probably don't have enough time now. So we cool the atoms down with laser beams down to tens of microkelvins, and then we ionize them with another laser. So we excite them to an excited state, and then we hit them with another laser, and we bump them up till the electron just falls off the atom. And so you've got positive ion and a negative electron, and because the laser is exactly at the right energy and the atoms aren't moving, there's no Doppler shift, we can just get the electrons off, and they just sort of hang around until we suck them off with an electric field, and we make a little bunch of electrons. They're not expanding. Electrons are very low mass, so normally if you make a bunch of electrons like an electron microscope, they just explode all over the place, and you use, in a microscope, they let most of them go away and just take a tiny fraction of them going down the column. But we have electrons that are all going in the same direction like a laser beam of electrons. They're very cold, like a laser beam is cold. They're all travelling exactly the right direction where we want them to go. And then the idea is to collide those with molecules like protein molecules, membrane proteins and so on, or viruses. Watch where they go to. They scatter and diffract. We know where they come from very precisely. We know where they go to very precisely. We can calculate back the shape of the object that scattered them, and therefore get molecular structure at nanoscale, atomic scale, and at very high speed. We do pulses that are picoseconds long, so we can do dynamics of protein folding and so on. So we're only that far along a very long journey on that, but it's going very well. We've got some very nice publications. And I also do a whole lot of work in other areas, and I've also started a little company called Mog Labs that makes lasers based on technology developed in my lab. Because to do experiments, I'm an experimental physicist, we have to do things, we have to use machines that you can't buy, equipment you can't buy, so we've developed our own. When we did that well, not due to me, but my colleagues and so on, we made them very well, and people said, oh, I want one of those, and we started selling them. And, so if you want a good laser, a really, really good laser, they are shipped around the world, hundreds and hundreds of them now. I'd be very happy to give you a good deal. I'll tell you more about them in class, but lasers and electronics and stuff.